Okay, I thought I would go over a little bit of this 11-2 because it gets a little confusing, and even though we have the video of the other gentleman discussing and describing these things, I was going to do this as well. But this is 11-2, surface area of prisms and cylinders. And of course, to begin with, they define a prism, and I've given you the vocabulary sheets. His video also defines these formulas, and you have the vocabulary sheet, so you need to write these down. But first of all, what is a prism? A prism is a polyhedron with two congruent parallel faces called bases. So both of these are polyhedron, okay, because all their sides, all their faces are made up of polygons, but they have a pair of parallel faces, one pair of parallel faces, at least one pair. All right, so a polyhedron with two congruent parallel faces. So this top and this bottom. This is called a pentagonal prism because its bases are both pentagons, and then the sides are the lateral faces, and then the lateral edges. So we have the two bases, lateral faces. These lateral faces in this case are rectangles, but they're all polygons, all right? And the two parallel congruent sides are the bases. The other faces, like he said, are called the lateral areas, and you name the prism depending on the shape of the bases. That's pentagonal. This is a triangular prism because the two parallel congruent faces are triangles. So this is a triangular prism, and then of course the lateral areas or the lateral faces here are also rectangles. Okay, so there are rectangles in this and rectangles in this one, so the bases were different. Okay, now they talk about an altitude. The altitude of a prism is the perpendicular segment that joins the planes of the bases. So any one of these lateral edges could be considered an altitude, or the height. The height is actually the length of that altitude. Okay, so the height h of the prism is the length of the altitude. So it's the distance between the two bases, the distance between the two bases, or the length of one of these lateral edges. Now that's true when it is a right prism. A right prism means it's at a right angle, stands at a right angle. This is a right prism, right prism, right prism. This is a right prism, it's just laying on its side. These are oblique prisms. Now oblique prisms are a little bit different. You have to find the height outside, and in our book and what we're doing, we're not finding any areas or surface areas or anything of oblique prisms, but oblique are the ones that just kind of, they lean over to the side. Okay, but the ones that we're going to be doing are right prisms. So in a right prism, a lateral face, the lateral faces are rectangles, just like this one, this one, this one, this one. If you look at the lateral faces, the side, lateral means side, right? The side faces, those are rectangles. And the lateral edge is an altitude, or the length of the lateral edge will be the distance between the bases, which will be the height of the figure. In an oblique prism, some or all of the lateral faces are non-rectangular. See, they're parallelograms. This would be a parallelogram, the lateral faces. These would be parallelograms. And you have to find their heights a little bit different. Okay? All right, so that's just some of the definitions and some of the terms. You'll hear me talk about a prism quite a bit. What kind of prism is it? Is it pentagonal? Is it triangular? Is it hexagonal and hexagons? Is it octagonal or for octagons? You know, just different types of bases that they can have. The polygons are going to be bases, just different types of bases they can have. All right, over on the next page, they're going to talk about, and on some of the how you find the areas, and we have two areas we'll find. Lateral areas. The lateral area of a prism is the sum of the areas of the lateral faces. If you add up all the lateral faces, see on this one, we would think of the bases being, I guess, the bottom and the top. Actually, in a rectangular prism like this, you could use bases as the bottom and the top. You could do the front and the back. You could do the other two sides. But usually when we see it sitting like this, we think of the bases of the bottom and the top. So this base down here and this base down here. So the lateral edge or the lateral area would be just adding all the sides around it. It's almost like if you had this box and you wanted to cover the outsides with paper. How much paper would it take? How many square centimeters of paper would it take to go around the box? Or if you're labeling the box or something like that, putting a label around the outside, not covering the top and the bottom, just covering the sides. That's what they mean by lateral area, around it, okay? Then they have surface area. Surface area is the lateral area, all this around there, plus the bases. You add the bases in. So there's going to be a quick and easy formula for doing that. But before we do that, they want us to look at it using a net. Now, a net is how, when you unfold, and we looked at nets our very first week In this class, we talked a little bit about nets. But if you unfolded this box, it would look something like that. Of course, you could change it up. It wouldn't have to look exactly like that. You could have put these two, which represent the bases, you could have put them over this one if you wanted to, and make it look a little bit different. All right, so then they're talking about the surface area drawing a net. See, when we took this thing apart, it's seemingly, I guess you'd say, its width, its height, and its depth. So the depth is 3. Those would represent 3. The width would be 4, and then the height would be 5. And then putting those values on these different rectangles throughout the picture, we can find their areas. Like this one would be 3 times 4, because the area of a rectangle or a parallelogram is the base times height. So that's 3 times 4. That's 5 times 4. There's another 3 times 4. This would be 3 times 5, 4 times 5, and 3 times 5. So what they did is they added all those together to get the surface area, all of them. We had a 5 times 4, a 3 times 5, a 4 times 5, and a 3 times 5. Okay, those. And then we had the two bases, the top and the bottom, 3 times 4 and 3 times 4. So we had 20, 15, 20, 15, 12, 12. So you got 94. So it's 94 centimeters square would be the total surface area. That's all, everything. This is the lateral area here. And then these are the bases we added in. See, if we would have stopped here and not put in the two bases, that would have just been the lateral area. See, if we didn't put the two 12s, we could just say 15, 15, which is 30, and 40, it would have been 70. So 70 was just the lateral area. That would be the area of the sides. But then when we throw in the two area of the bases, we add 2 more 12s, and that's where we got 94 for the whole surface area. Now, this next one says we want to do that one as a net. So if we took that apart as a net, let me kind of draw it real quick. We're going to have 2 triangles as our bases, and they're congruent triangles, and we'll label them in just a minute. And then, of course, the way that's made, it would have 3 rectangles. So I'm going to say 1, and they're wrapping around the triangles. So there's 1, and there's 1. And if I put my dimensions, and I know this is rough, and I'm trying to do this kind of quickly, but this length here was 12, because that was kind of the length or the height of the figure, if you want to say. These would all be 12. And around the triangle, we had a side that was 6, 6, and the other 2 sides were 5 and 5. So what we got to figure out here then, how long is this segment? Is it 6? No, it's 5, because see, it would fold up, this would fold, and this would meet here, and it would meet that one there, so these are 5. So those are all my dimensions. So if we're trying to find the surface area of this one, first we can look at the lateral areas. This is 5 12s, 60. This is 6 12s, 6 times 12s, which would be 72. 5 times 12, another 60. So we have 2 that are 60 and 2 that are 72. Now the tricky part is going to be find the area of the triangle. Well, to get the area of the triangle, we got to do a little work, all right? Because I didn't do a good job drawing that, it's kind of off to one side. But if we draw in its height, and we're just using 1/2 base times height, area equals 1/2 base times height. That height, how big would it be? Well, it's an isosceles triangle, so it bisected this, and it's 3 and 3. And you should recognize this, but if we didn't, we use the Pythagorean theorem. 3 squared plus 8 squared equals 5 squared. So it's 3, 4, 5. That's a Pythagorean triple, right? So that's 4. See, I told y'all when we went over Pythagorean theorem that we do those triples quite a bit. 3, 4, 5, 6, 8, 10. This would be a 3, 4, 5. But you'd plug it in the Pythagorean theorem if you didn't know that, if you didn't recognize it. You'd say 3 squared plus 8 squared equals 5 squared and solve it. But that gives me the height is 4, so it makes it a little easier. 1/2. The base was 6. The whole base is 6. The height is 4. So half of 24 would be 12. So the area of these are 12. So this is 12, and this is 12. So for the total surface area, we just add up all those areas. We had 60, 72, 60, 12, and 12. All right, so that's 172 plus 24, right? Do this real quick on the calculator just to make sure I'm doing it right. Yep, 216. 216, and that's, did they give us a unit? Yep, centimeters squared. So that's solving using a net. So we had to find the area of the triangle.
Please come to the office, Coach Smith.
In the area of the rectangles. You can tell I'm doing this recording at school. All right, so that's how you would find it using a net. And it says, now it says, you can find formulas for lateral and surface areas of a prism by using nets. Okay, now of course we just added them up, and basically these formulas are really kind of simple. I'm just going to show you the formula down here, and they're talking about the net because when we unfolded this thing, we got A, B, C, and D. That's the perimeter, or the distance around the top, the perimeter of the top, and then all we had to do is multiply that times the height, the height of it. So it's the perimeter times the height. It's like if we could stretch a rubber band around this and then move it all the way down, it would cover the sides, right? So the perimeter, the distance around the base, times the height, gives us a lateral area, the distance around it, the lateral area. So that's all of this portion, the side area or lateral area. And then all we had to do is add in the bases. So the formula for the surface area, to get the surface area, is the lateral area, which is perimeter times height, plus two bases. The bases are the same. And depends on what the base is. Here's the trick, finding the base. In a rectangular solid, of course, the base is going to be a rectangle. It'll be easy. It'll be length times width. That'll be simple. But if it's a pentagon, if it's a triangle, like the last one we did, we had to find the area of that triangle using 1/2 base times height. That's when it becomes tricky. So finding the area of the base is the tricky part. So those are the formulas. Now we could substitute in here and just put P times H if we wanted to for lateral area. And what I generally tend to do, even if they ask me to find surface area, I find lateral area off to the side, then I go down and finish the surface area by putting in the lateral area. Just like the area of the base, you're most likely going to have to do that off to the side somewhere and then bring it back to the formula to find the surface area. All right, so let's look at one that they have here in the book that they're solving that way. And this, again, is a triangular, right triangular prism, okay? And this one involves, we got bases that are triangles. And so they're asking, what is the surface area? What's the surface area? Well, before I find the surface area, I'm going to have the lateral area, because surface area is lateral area plus 2 times the area of the base. So here's what they had to do first. This base is a triangle. It's a right triangle, fortunately. And notice that it is a right triangle with a side 3, a side 4. So guess what the hypotenuse is going to be? 5. Okay? So we can use the Pythagorean theorem to get that if it's not a triple. But we, oftentimes in a book and things, they'll use triples, as I said before. So we know that that this side here is 5 centimeters. Okay? So that's going to make this a little easier, because to find the lateral area first, well, the perimeter will be just add those together. 3 plus 4 plus 5 is 12. So we've got to find the perimeter to find the lateral area. Finding the lateral area is the perimeter times the height. So the perimeter is 12. The height of this is 6. That's the distance between the two bases, the two congruent triangular sides or faces that are congruent, or parallel. So that's 6. So the perimeter, 12 times 6, gives me 72. So 72 centimeters, just centimeters because, centimeters squared because it's the lateral area. That's the area of, if we were just going to put a label around the outside of this thing and not cover the top and the bottom. Of course, they wanted us to find the surface area, so we got to carry that further. Surface area, remember, is lateral area plus 2 times the area of the base. And to get the area of the base, we'll back up here. It's a triangle, 1/2 base times height. Luckily, it's a right triangle, so when we find 1/2 the base and the height of the two legs, 3 and 4. So 1/2 of 3 times 4, that was 6. Okay, so that's the area of the base. So our lateral area, as we found it up there, is 72. 2 bases, 2 times 6, would be 12, so 84, and that's 84 centimeters squared. That would be the answer. Okay, so that's not too bad, but then it can be a little tricky. Now, here's what I'm going to try to do. I'm going to try to do this next one on another sheet of paper, and of course, the tricky part is I'm going to be writing and try to display that picture. So let's see if I'll have space for that. What is the lateral area of the prism? Now, lateral area in this case is going to be fairly easy. Remember, it's the perimeter, lateral area, the lateral area. Now this one's laying on its side. It's the perimeter times the height. The perimeter is going to be the distance around this, right? Now notice that's a hexagon. It's got 6 sides, and every side is congruent, so at 6 sixes, it's going to be the perimeter, right? So the perimeter would be 6 times 6, or just 6 added 6 times, which is 36. So it's 36 meters is the perimeter. And the height is the distance between the two bases, so it's going to be 12. It's laying down. This one is. We could set it up. Sometimes they'll be laying down this way. And even though we call it height, remember it's the distance between the two parallel congruent sides. So once you determine what the bases are, it's the distance between those two. So for lateral area, it's going to be pretty easy. Lateral area is the perimeter, which we just said is 36 meters, times the height, which is 12 meters, and then 12 times 36. And I happen to have a calculator. So 12 times 36, and the answer was 432 meters squared. That's the lateral area. Now, the next thing they asked us to do after found the lateral area, they go on to say, what is the area of the base in the simplest radical form? All right, now this base, remember, that's a hexagon. I'm going to try to draw a quick, and remember, to find the area of a hexagon, the area is 1/2 apothem times perimeter. Now we already know the perimeter. We're going to have to find the old apothem. The perimeter is 36, remember. But we got to find the apothem. Now the apothem, remember we draw the little triangle. This is a hexagon, so it's going to be a little easier. The angle at the top is going to be 60 degrees. And we draw the apothem. It bisects it. That's 30. The side was 6, so that's 3 and 3. So my apothem is 3 square roots of 3. Because 3 here was the short leg, right? It's the short leg. And so the long leg, which is the apothem, is 3 square roots of 3. So we plug that in there, 3 square roots of 3. So we have half of 36 times 3. I don't know why it's taking me so long. It's 54 square roots of 3. And of course, that's the area of the base, and that's also meters squared. Meters squared. So that was the second part of that. Now we can find the surface area, because surface area, the formula is the lateral area plus 2 times area of the base. And so this is where we found area base, B. And the base can be different things. In this case, it was a hexagon, so that makes them a little more complicated. So when it was a hexagon, it makes it a little harder. So all we have to do now, we've got everything, though. We just plug it in. The surface area is the lateral area, 432, plus 2 times 54 square roots of 3. So that's 108, right? 108 square roots of 3. And that's meters squared. Now let me see. How did they want our answer? They said, what is the surface area rounded to the nearest whole number? So we got to put that in our calculator to find the nearest whole number. So 108 times the square root of 3 plus 432. And to the nearest, did it say nearest whole number? Yeah, nearest whole number. So I'm going to get 619 meters squared. And that's the answer. Okay, so these are a little involved. There's a lot of side work you had to do. We had to find the perimeter. We had to find the area of the base. So there's a lot of side work you can do before you can plug it into the formula and solve them. They're not overly complicated. It's just that you've got to make sure that you find the area of the base. And the area of the base is going to be the tricky part, depending on what the base is. We have bases that are trapezoids. One of the problems on your worksheet, there's a trapezoid. The area of a trapezoid is 1/2 the height times the sum of the bases. Just look at your formula sheet and find the area of those bases, and then you can solve them. Okay. All right, and then the last thing that they had in this section was cylinders. Cylinders, it's really kind of the same formulas, but we'll get to that in just a minute. But a cylinder is a solid that has 2 congruent parallel bases, just like a prism does, but those bases are going to be circles. Okay, so it's like a prism, but but it's not made up of polygons. It's got two circular bases, okay? And then there's got a lateral area the same way. The altitude of a cylinder is the perpendicular segment that joins the planes of the bases, and the height, h, is of the cylinder is the length of the altitude. So the distance between the two bases, whether it's laying down or standing up, that's going to be the height. This is much easier to distinguish the base, and the bases are circles, so that's easy. We know the area. We know the area of a circle formula. We know the circumference of a circle formula, and it never changes. So cylinders are a little easier than prisms because the bases are always circles instead of different types of bases. Then we have an oblique cylinder over there to the side too, one that leans over. So right cylinder and oblique cylinder. There's those definitions, and you'll be able to apply those and put those in your on your vocabulary sheet. All right, so let's just kind of quickly look at that, and they show us a net. The net for a cylinder. Net for a cylinder would be one big rectangle and two circles. Okay, one big rectangle and two circles. And the height is the width of the rectangle. The length of this rectangle is the circumference. It goes around that circle, right? So it's the circumference of the circle. Okay, so instead of saying perimeter, we say circumference. So the lateral area, here's the circumference, 2 pi r. 2 pi r, or diameter times pi, right? If you had the diameter, you say diameter times pi, but they write it as 2 pi r. So 2 pi r, that's the circumference, and then times the height. That's it. That's lateral area. So it's the length around the circle, the circumference, times the height. And again, it's like painting it, see? Or you can think of this as like a can. This would be the label that goes around the outside of a can of beans or corn or whatever you got. You know, that rectangle will be the label. Okay? And then for the surface area, same thing as with a prism. You do the lateral area plus 2 areas of the base. The base is the circle, so pi r squared is the area of the base, but there's 2 of them, so 2 pi r squared. Okay? So those are the formulas. Now, you know, sometimes they write surface area like this. They expand it. They say, all right, there's the lateral area, 2 pi rh plus 2 pi r squared, 2 times the area of the base. So those formulas are really easy, straightforward. They have to either give you the circumference or the diameter. You know, if they give you the diameter, you half it before you plug it into the formula, right? And then they have to give you the height. There's no finding it like using the Pythagorean theorem because there's no triangles or anything like that in it. So those are pretty straightforward, pretty simple. You know, here's a problem where they said multiple choice problem. The radius of the base of a cylinder is 4 inches and its height is 6 inches. What is the surface area? So all we'd have to do is first the lateral area would be 2 pi rh. So 2 pi times 4 times 6, the radius times the height, plus 2 pi r squared, 2 times pi times the radius squared. So they get 48 pi and 32 pi, which is 80 pi. 80 pi, a lot of times we'll leave them in terms of pi, then many times they'll ask you to round it to the nearest whole number. That's how simple it is. You just plug it into the formula, nothing to it. Okay, I hope this will help going along with what he did in the other worksheet, in the other video, and maybe this will help you as well. So good luck doing your worksheet.